Okay, today is May 3rd. It's a Wednesday because I know that because tomorrow is my favorite day of the year. Star Wars Day, May the 4th. We have 4 warm-ups here from Chapter 9 on inequalities, all from 9.1 and 9.2. The first one says twice a number is at least 10. So what I'm doing is I'm giving you one of the 3 formats. You give me the other 2. In this case, the format you're first going to give me is an inequality. So twice a number, algebraically speaking, is 2 multiplied by a variable. In this case, we'll use x. We could have used n. Is at least 10. So from an inequality standpoint, we've got 2x has to be greater than 10. Can it be equal to 10? Yes. So therefore, we're going to use a line underneath our inequality sign to say 10 or more, at least 10. So that's 1 point if you wrote that. Another point would be to take that and to write it as a number line. Now, question. Can I write 2x is greater than or equal to 10 as that form? No. In order for me to write it on a number line, what do I have to do? Solve the inequality. So I'm going to solve it by dividing both sides by 2. And x will be a value greater than or equal to 5. That is what I'm going to graph on my line. Closed boundary point, the number 5, the number 4, and the number 6. Any number greater than or equal to would place my inequality sign that way there. So, step 1, write your inequality. Step 2, solve your inequality. Step 3, write your inequality as a number line. And finally, the last thing you're going to do is write your set of numbers using the bracket. Any number greater than or equal to 5 means 5, 6, or 7 are all valid numbers in that set of the inequality. In the second question, we are given a number line with an open boundary point, which means it is less than the number 1.5. So x represents, we actually in our head when we read it, we don't say x, we say all numbers, right? When I read x, I actually say all numbers. So all numbers less than 1.5 is what that number line is showing us, not including 1.5 because it would be closed boundary. And I'd write down all numbers less than 1.5. Are there other ways to write it that's appropriate? Yes, but that's the one I'm going to use. And then for my set of numbers, numbers that are less than 1.5 are 1, 0, and -1. You could have different ones, but those 3 are going to be the first 3 integers that are valid within that set. 1.1 is also valid, but I'm just going to put 1, 0, and -1. Third question, if I interpret it, it's going to be half of a number, or half of a number, has a value greater than or equal to 4. Another way to say that is half of a number is at least 4, right? Half of a number is at least 4. That's a better way of saying it without using less words. In order for me to graph it on the number line, just like in question 1, I have to solve it. So I'm going to multiply this side by 2 and multiply this side by 2. And all values, the solution will be all values greater than 8 or equal to 8. 8's my middle, 7's over here, 9's over here. Closed boundary point because it can be equal to it, and any number greater than or equal would make the line go that way. Set of valid numbers would be 8, 9, 10, as Buzz Lightyear would say, to infinity and beyond. And finally, our last question is a double boundary. When we read it and write it as a sentence, it's a little tricky. I have to read it this way first. So when I read it, I say all numbers greater than or equal to 4, or all numbers greater than or equal to 4. And then I'm going to use this but, because now I have to read it this way. All numbers less than 5, but less than 5. So when I read that inequality again, I'll use a blue marker. All numbers greater than or equal to 4. All numbers less than 5. So then when I read it, all numbers greater than or equal to 4, but less than 5. That's what that double inequality states. When I take that and put it on my number line, my boundaries will be 4, 5, oh no, I guess 4, 4.5, and 5, I suppose. I don't actually need this one. In fact, I'm going to erase it. I'm not even going to have it there. You can if you want. It doesn't matter. And then all numbers greater than or equal to 4 means it's a closed boundary on this. All numbers less than 5 means an open boundary. And all the numbers on that red spectrum would be numbers that would fit into that inequality. Those numbers would be 4.1, 4.2, 4.268, random complete number all the way to 5.